Good morning. This video is going to be about the project. So hopefully I can give you some tips in the next few minutes that will help you as you go forward with the project. So the first thing I want to say is that there are only three different hypothesis tests that we use on the project. We use the two-sample t-test, and we use ANOVA, and we use linear regression. And so here is the actual code that runs each of the three. Again, we're using the independent sample t-test, not the matched pairs. So t-test underscore IND. And notice that we have to put in two arrays. We create arrays for the data for the two groups that we're comparing. And the stats.f underscore one way. Again, we put in arrays. The reason I put a ... is because in the project, we'll need 8 or 9 or 10 different arrays to run this. And the f underscore one way ANOVA will allow us to put in as many arrays as we need. So we can put in 3 arrays if there are 3 groups, or 9 arrays if there are 9 groups. And then stats.linregress also, I put in 2 arrays. The first one is the x, the variable that goes along the x-axis, and the second is the variable that goes along the y-axis. And I want to make kind of a big deal out of this because these methods, these functions all require arrays, the data to be in arrays, not tables. Okay, and I'll show you on the project in just a minute, those arrays are easy to get at. But if I try to use them like tables, if I try to put in a table.select to get the correct column in there, it will screw up. And finally, there's this new tool called group stats. Very useful tool. But we've never really gone over it before, so I want to explain that table means the name of the table where the data is, and group means the grouping variable, and data means the name of the numeric variable. So, I just wanted to coach you on that to let you know how to use the group stats variable. And I believe that we need quotes around those variable names, table names, group names, variable names. Okay, so let's actually look at the project for a moment. So the project, one thing to notice is that the correct updated version says it calls itself biology and chemistry project. So some people have been confused, like, wait, is that the right one? Well, this just uses a data set that's biochemical, and so the statistics are there. So you can read about the experiment. The biggest thing is that bigger numbers are going to mean the antibiotic is more effective. Okay, so we have a larger zone of inhibition. So the thing that we're measuring, the numbers that we get in our data table, higher is better, lower is performing less well. Okay, and then I also need to talk about how this data gets imported. Okay, so they're importing scipy.stats as stats. So I've had people who have asked me about, oh my gosh, I've been trying to run scipy.stats something, and it won't run. I get a name error. It says, scipy, not defined, not understood. And you're like, what? How does the computer not know what scipy is? Well, it does, but it knows it as stats. So in the project, I don't use scipy.stats. I just start with the stats. And that's what I put on the slide. So if we go back there, sorry, let me get the, you notice that I put just stats.t-test independent. That is what I'm going to use on the project to run the t-test, stats.f one way and stats.linregress. I do not want to refer to scipy because of the way it's imported, okay? And in this first This first one, I just want to note, this is research question 1. It says use the group stats function. Okay, here you go. So you type in group stats, and what do we need? Well, we need the table name, which is penicillin, right? And then we need the compound, that's the grouping variable, right? So we'll use that column, the compound column. And then we'll use E. coli, which is the numeric variable. Okay, so that's how that works. I just wanted to go over that with you. I also wanted to point out that they created these arrays. These are all arrays. On the left-hand side here, these are the names of arrays. How do I know that? Well, they use the dot column method. And if you take a look at this table, you'll see that there are 3 columns. The first column is compound, the second column name is E. coli, and the third column name is S. epidermis. Okay, so column 1, well, the first column, of course, the computer counts it as 0, column 0. So column 1 just refers to the E. coli column. So when I need to do these arrays below for the S. epidermis in research question 2, what do? I can pretty much just copy paste this, except all the column 1s need to be column 2s, and all the capital E's need to be changed to capital S's, so that I have different arrays, different array names for the S. epidermis. Okay, so I just wanted to notice that these are all arrays here. And then it shows you how to run the one-way ANOVA. Okay, and there's one more exciting thing. All of this code runs these box plots. Again, you can copy paste, and what's going to change in group 2 is that we're going to rename all of these with a capital S in place of the capital E's. So we can basically use the same box plot for research question 2. So I just wanted to go over a couple of those things about research question 1 and research question 2. What is the null hypothesis for ANOVA and the alternative hypothesis? I'm going to go over some specific examples in another video later this morning, so we'll talk about that. Basically, we're checking to see if all group means are equal, and you can see from the box plots that no, it doesn't really appear that all the group means are equal. It appears that the groups have some different characteristics. All right, so we would reject the null and say that there are differences in group means for these particular compounds, these E. coli compounds. All right, and ANOVA lacks specific details about that. So that's why we run the group stats, so we can see which groups are different and how, which group means are different and how. Okay. Again, 2 sample t-tests, so I showed you about that. The second research question, basically it wants us to take the penicillin table and use column 2, which is S. epidermis instead of E. coli. Again, I encourage you to to use the question 1 as much as possible for all of these parts. So to reiterate, right, they give us all the details in question 1, and I've tried to make sure that you understand the group stats and so forth. And then we should be able to use the code blocks given in part 1, and we're going to have to change them a little bit. We're going to have to tweak them, but they'll help us complete part 2. Okay. And in research question 3, we're told to run 2 sample t-tests. So that's just in the project. It says run a 2 sample t-test in the cell below and interpret the results. And then it says repeat the analysis in the previous part. So again, a 2 sample t-test. So that's question 3. In question 4, I'm not going to tell you exactly what to run here, whether it's a 2 sample t-test or not, but I do want you to note that there is some very similar language, and these items are very similar to the ones in research question 3. So that's my hint on research question 4. So run a 2 sample t-test for question 3 and note the similarities between question 3 and question 4. Now, research question 5 is linear regression, and there are 2 steps. The first thing I do is a scatter plot. Now, remember that scatter is a table method. Okay, so that's the only time I'm using a table method. And then the second step is to do a linear regression. So if I find an association using the scatter plot, then I use the linear regression, which requires the data to be in arrays. Now, as we just saw in that group stats that I was showing you, yeah, all the arrays are already set up there. So we can run this linear regression without doing a ton of extra work. Okay, so remember this is dot scatter is a table method, and I just put the name of the table in front, and then inside parentheses I put the names of the columns that I want inside parentheses. Okay, and I make sure that when I run the linear regression, I'm doing it with arrays. So tables for the scatter plots and arrays for the linregress, which is the name of stats.linregress is the name of the function. Okay, so those are the big tips that I have for you. Again, to remember the, sorry, there it is. To remember this, that we, in the project, we imported scipy .stats as stats. So that's what we're going to call. And I do want to make this point. If you go into the hypothesis testing help, which you should, there are some really good things in there. But notice that they import scipy.stats. So when they call it, when you copy paste in from the hypothesis testing help, it opens with a scipy.stats because it just imported it. It didn't import it as something. But just be really clear that on the project, I don't need the scipy because I imported the scipy.stats as stats. So that's something that's been giving people trouble. Group stats, we haven't seen that one before, so I wanted to give you some information on that. And again, the arrays, right? Every single one of these tests, the t-test underscore independent, the f underscore one way, and the linregress, all 3 of those require arrays. They're not table functions. I have to actually have the arrays. Now it's nice because the data is broken down into arrays for me. After I do research questions 1 and 2, I have all the arrays I need. So that's a quick overview. I'm going to do another video to follow up with examples of a t-test, a linear regression, and an ANOVA. All right, I hope that helps. Good luck on the projects.